All right. So today we're going to be teaching you how to draw the Lewis structure of NaHSo4 here. And we're going to be showing you all of the possible resonance structures for it. This is a bit of a complicated molecule, so it's going to be a bit of a process. But as you can see, we have NaHSo4 here. So we get, let's see, how many? 11 valence electrons from,
one for sodium.
Oh yeah, 1 valence electron for sodium, 1 for hydrogen, let's see, 6 for sulfur.
And then 24 for the 4 oxygens.
Mm-hmm.
Add that up, you get 32. 30 here and then the other 2. And so just logically, we'll start by placing the sulfur in the middle. Just good practice. Start with this. And we'll just draw out all the molecules and give them 1 bond each. This is easily the best way to start. So I'll put all the oxygens next to the sulfur to start. And then I'm actually going to erase this to give us space to go. And while we could put more stuff on the sulfur, as you'll see in the long run, it's more beneficial if we just take our sodium and hydrogen and bond them to an oxygen here on the outside. Will be the best thing to start. So if we count up all of the ones we used, we've got 2, 4, 6, 8, 10, 12 views, right?
Leaves us with 20 valence electrons to use.
Yep, so it's 32 minus 12. We now have 20 valence electrons left.
Mm-hmm. And we can use those for our oxygens. We can fill some of the octets there. As you can see, if we get double bonds between the sulfur and the oxygen, that will satisfy some of their octets, put some lone pairs on there as well. So as you can see, there is 8 on each of these, and that satisfies their octets.
Yep. So that we did 6, 2, 4, 6, 8, 10, 12. So we did 12 more.
Leaving us with 8 more.
Yep. So the sodium and the hydrogen are already happy with their 1 bond. So we can use our last 8 to satisfy the 2 remaining hydrogens, or 2 remaining oxygens, sorry, giving them 1, or giving them 2 lone pairs each, which gives them 2 lone pairs and 2 bonds, which will give them 0 charge. And this structure here satisfies the conditions for every single atom without having to use formal charges. Hello, pause on that. This is RJ in post-production. I realized that this Lewis structure we just drew is a little bit wrong because we didn't realize somehow that this is an ionic compound, and thus you wouldn't draw it like this. The sodium wouldn't be bonded with the line to the oxygen like that. Both those electrons are actually completely unshared by the oxygen in a structure that looks something like this. Yeah, this is the correct structure. And that means that all of the resonance things that we're going to talk about after this are now wrong. So I'm doing this all in a post-production. So we actually have 3 other ways to draw this by moving the negative charge to all the 3 other oxygens. And remember that it's not on any one at any given time. It's actually just partially shared by all 3 of them. So all 3 of them will have a bond length somewhere between a single and double bond. And then there is also another structure worth mentioning. It is a much more minor product. And we can take away another double bond to have 2 negative charges on these 2 oxygens here, and a positive charge on the sulfur in the center. And while this is a minor product, it still helps us understand that since oxygen is more electronegative than sulfur, these electrons are not shared equally in the bond, and thus there is some partial negative charge on the oxygen, more than you would expect to have from just that 1 negative charge we had earlier, and a partial positive charge on the sulfur.